My goal in this video is to highlight three very important ideas that we're going to study as we talk about sequences and series. And that is the idea of what a sequence is, what a series is, and what the sequence of partial sums of this series are and what they can tell us. These are three separate ideas that are all very important. So I've been asked to consider the sequence. I don't have anything that important to say about it. And in this video, we're not going to do anything very formally, just use these as examples to explore sequences, series, and the sequence of partial sums. So in looking at this, I just want to write out the first 4 or 5 terms of this sequence, and then maybe talk about it a little bit. A sequence is a list of numbers. So this list of numbers is just generated by that nth term formula. So let's plug in a 1. When I plug in a 1 on top, I'll get minus 1 to the second, which is just 1 over 1. We'll get out a 1. Next up, we'll plug in a 2, and on top I'll get a minus 1, and on the bottom I'll get that number 2. And right away I can kind of see what this is doing, right? When we have minus 1 raised to either the index or plus or minus 1 or some number, it's going to make our sequence alternate in sign. When I plug in an odd index like 1 or 3, I'll get out a positive 1 here. When I plug in an even index, I'll get out a minus 1. That makes it a pretty easy job to write out these terms because the bottom's just in the place I am in the sequence. And so there are the first 5 terms of this sequence of values. And I could even think about those on a graph, this list of numbers. I got a 1 and then a minus 1/2. And I'd think about something like this, and just from having plotted these points, I can tell what's going on. It looks like I'm converging to 0. So I could write here that this sequence appears to go to 0 as n goes to infinity, that we're converging to 0. Well, in fact, the nth term formula here is always less than 1 over n and always greater than minus 1 over n. And I could use the Sandwich Theorem to establish this limit. Because the limit as 1 over n and minus 1 over n as n goes to infinity is 0. And we'll just pretend I said all that in the right order. The limit as n approaches infinity of minus 1 over n is 0, as is the limit as n approaches infinity of 1 over n. So the squeeze theorem does allow me to say that this sequence converges to 0. All right, so now I want to talk about the series that's based upon that sequence. The sequence itself is just a list of numbers. Now the series takes that list of numbers and adds them all together. Just like the sequence, the terms in this series alternate by sign. The only difference here, I'm adding them all together, and I've even written out a few more terms here. And the pattern would continue. And now the question is, as we continue to add, and in this case subtract terms, does the number get closer and closer to another number? And that's where we get the idea of the sequence of partial sums. S1 always just the first term, S2 the sum of the first 2 terms, right? So 1 minus 1/2 is 1/2. The third element in the sequence of partial sums, I need to add a 1/3 to that, and no secrets amongst us here. I'm just going to say 1 minus 1/2 plus 1 over 3, and I see that I get 0.83 repeating. The fourth element in the sequence of partial sums, I just now add that minus 1/4. 0.583 repeating. Let's add that plus 1/5. Minus 1/6. s sub 7, the seventh element in the sequence of partial sums. And here I'm just going to say dot, 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 because I don't see the pattern. All right, and we could keep writing this out. Well, we have a sequence. We add all the terms together to get a series. And in writing out the sequence of partial sums, what we're trying to figure out is this series converging? As I continue to add the next term, are we getting closer to a single value? Because we're adding and subtracting here, I get numbers that are oscillating from being above and below a value. This sequence of partial sums actually does converge. We're not going to show that formally in this video, but it's kind of surprising maybe to learn that this series, this sequence of partial sums, converges to the natural log of 2. About 0.693. That's the value we're bouncing around as we add and subtract other values. Later on in the class, we'll see why that's true and establish that rigorously. But for now, the idea is here. I have a sequence. When I add all of those numbers together, that infinitely long list, I get a series. We explore the convergence or divergence of that series by looking at the sequence of partial sums. Just the sequence that happens as I keep adding terms in order to the series.